Okay, so now we're starting 2.7, proving segment relationships. The hardest one, I think, out of the whole of the proofs. The reason why, even though last period 2.6 you were doing the algebra and then writing your proof statements, this time you're just using the letters from the diagram they give you, and then expressing them in terms of their notation as well. So be very careful. Okay, notice first of all there's no new vocabulary, so all the vocabulary you've already done in previous exercises. Okay, today really we're not going to do any work on the ruler postulate, but the segment postulate, you will be doing a lot of it today. But have a look at the segment. If you look at what they're doing, they're separating A, B and C between AB and BC, and then giving you the whole length AC. Under normal circumstances you will have numbers for this, but today you're just going to be using the letters, the AB, the BC and the AC, in order to write your two-column proof. And example 1 is the perfect example of what you are going to see when you get a question like this. If you notice, every one of them are letters. There is no algebra at all. When you write a two-column proof, the first line that you ever use is the given. So there's always going to be the first line. Okay. Whatever you've got to prove is always going to be the last line. So really all you're doing when you're proving is showing all you're working out and getting to go from the given, which is the first line, to what you've got to prove, which is the last line. Okay, here's example 1 in its entirety with the statements and the reason. If you notice, look, the given statement up here is the first line here. Okay, what you've got to prove here is also the last line down here. So really all you're doing is filling in the gaps between what you've been given and what you need to find. Okay, so let's have a look at it. Your given statements is there, but look now at line 2. What's the difference this time? It's just your notation. So the first line, what you got to do is work from the first line to the second line. What's the difference between the first line and the second line? Well, obviously it's taking away the congruence, and it's talking about, remember in the exam, in the quiz, when you had just letters with no line above it, we're talking about distances. So the distance of CE is equal to the distance of FE. The distance of ED is equal to the distance EG. And again, you've got a new one, which is the definition of congruence. You've come up against this in 2.1 and in 2.3. See where to see where you go. Always go back to refer to your previous chapters. Okay, line 3. Line 3 is talking now of just one segment, and the same with line 4. Both of them, okay, are the segments FG to CD. Okay, and there's segment addition, because if you look at what they're doing each time, they're adding segment addition. Okay, and then finally you're working your way down. Substitution is the one that's going to cause you a bit of a problem, because you're substituting in letters for other letters. So in going from this line to this line, you substitute FE for EG and FE plus EG as CD, because it's the same distance. Okay, and there's where your substitution come in, and that basically is using proving segment relations without any algebra whatsoever. Okay, so let's have a look at this example 1 that they've given, and this is a typical exam type of question where you're given statements and reasons, and obviously you're filling in the gaps. So again, the first line, the given. All right, whatever has been given must be your first line. Should not be a problem for you. Okay, now what are you doing? JL and KM. Well, according to what you've been given, that is a given statement, But notice the difference between the line above and the line below. This time you've got no notation above it, so this is just the definition of congruent segments. Okay, shouldn't be a problem to you. The next line, let's have a look at what the next line is doing. JK, which is this section, and KL is this section. Well, that's got to equal the whole distance, so that's got to just be JL. Similarly with the next one, KL and LM, well, you've got the same middle letters, so you know that the distance must be from K to M. Alright, so what we're doing there, the next line, that's segment addition. We are now substituting in KL, which is, and we are just changing it around. This guy we're substituting. Okay, keep going. The next line, subtraction. Finally, F. Well, all you've got to do is whatever it equals must be the answer. So this guy is JK must equal LM. Substitution. Okay, and then obviously the last one, which is G, is what you need to prove. Okay, so your proof is JK, the segment JK is congruent to the segment LM. Simple, easy, we'll see. Okay, so let's have a look at question number 1. All right, do your little table, statement on the left, and your reasons on the right, and set all of them up like this. Okay, so on the left hand side, what have we got on the left hand side? Well, look at what you've been given. You've been given the LK is congruent to NM. Okay, and then you've got KJ is congruent to MJ. All right, and don't forget, both of those were given statements, so just write on the left hand side given. Okay, let's carry on with this left hand side. All right, we don't know what we're going to fit in the left hand side, but we want the definition of congruent segments. So let's have a look at what segments we know. We look at the line above, that gives you the line below. So LK, but with no line across, no notation, is equal to NM. Okay, and KJ is equal to MJ. Simple, easy. Look at the line above, see what happens to the line below. Okay, so where we go from there? The next line is LK plus KJ is equal to NM plus MJ. Okay, so what we're doing, we're actually adding. So it's addition apostrophe. All right, but just write addition, that will be sufficient to get the full marks. All you're interested in is getting the full marks. All right, so where do we go next? Well, we know that the next bit is segment addition. So what we add in together? Well, we'll add in together the two parts to make the whole one. So LK plus KL equals LJ. Okay, so there's one segment we've added together. Let's work the other one out. That's NM plus MJ, and that must equal the whole length, which is NJ. There's your segment addition. All right, then the next line, LJ equals NJ. In other words, the two segments equal each other, so we're substituting. And then finally, what you're going to find is that you've got LJ, and the line above it is congruent to NJ, And that is the definition, simplify it as well, of congruent segments. Okay, use shorthand if you can, it makes it a lot easier.